when you get something that looks like this on the homework and they're asking you to find, this is in the 10.2 homework, they're asking you to find the sine of pi over 4 multiplied by, say, the cosine of negative 5 pi over 6. All they're asking you to do is find out what the sine of pi over 4 is. So you'd look on your unit circle and you'd find the sine of pi over 4 is the square root of 2 over 2. That is what that is equal to. So then you look for where the cosine is negative 5 pi over 6. Now remember, we're going negative, so I need to go in this direction. So I'm going clockwise. So when I go clockwise, negative 5 pi over 6, I am here. My reference angle then is pi over 6. So I'm going to look for pi over 6, or if I have my unit circle, I'm just going to look at negative 5 pi over 6, which is the same as 7 pi over 6 if you're going positive. That's coterminal. And for that, we end up with that value here is going to be negative square root of 3 over 2. And it is simply just a matter of multiplying these two numbers, and that's it. That's all you have to do. And so you get a negative square root of 6 over 4, and that's as good as it gets. So when you're asked to evaluate something like that, you just go on the unit circle, figure out what the sine of pi over 4 is, or if it gives you in degrees, and whatever the cosine of that is, and multiply the two, and that's all you have to do. There's no real hard work on that one. There's no x, y, r stuff on that, because it's giving you the angle. If the only time you have to do the x, y, r stuff is when you're given something that looks like this, when I say the sine of theta is equal to negative 3 over 5. In that case, I don't know what the angle is, and I'm not necessarily chasing the angle, I'm chasing the relationship there. I'm looking for that ratio. So if I have something like that, I'm not necessarily looking for the angle, I'm looking for the ratio. The other thing that came up in the homework questions was one that looked like this. They asked for the tangent of theta is equal to 1 over the square root of 3. What we did yesterday is we did one that was similar, but I did sine. So the one I'm going to go back to this one, but the one I did yesterday is we did something that looked like this. We did the sine of theta is equal to the negative square root of 3 over 2. So I'm chasing the angle now. This one I actually want to know the angle because the one that we did yesterday said something about all that thetas that satisfy that. So it wasn't in an interval. So if there's any all thetas that satisfy that, I just look at the unit circle and I look to see where I have this negative square root of 3 over 2. Negative square root of 3 over 2 is the 60s in quadrant, reference angles of 60s in quadrant 3 and 4. So I know that my theta is going to be in quadrant 3 should be, let me see, that's 4 pi over 3 plus 2 pi k. And then also in quadrant 4 is 5 pi over 3 plus 2 pi k. Now, that's because I wanted all the thetas that satisfy this. If I go back up to this one, and on the homework, it's asking you for the answers that are in this region, theta, and then they say 360. Because they're telling you the interval in which you want to answer this, first of all, you're going to answer only those values that satisfy that. And second of all, you're going to answer it in degrees. So whatever this interval they're giving you in, whatever the units of that interval are, that's the units you answer the question in. So if that would have been in pi, then you would have said it was the answer's in radians. Because it's in degrees, we're going to answer the thing in degrees. So if I'm asked for the tangent of 1 over the square root of 3, what I know is that the tangent of my angle is equal to my sine of my angle over the cosine of my angle. So I'm going to look for, when I put sine over cosine, that the relationship there gives me 1 over the square root of 3. Now, if I just choose, starting with, and I'm going to do this in degrees, I start with 30 degrees, then my sine of 30 degrees is 1/2. My cosine of 30 degrees is the square root of 3 over 2. Now, if I put these over each other, and I put my sine and cosine over each other, then I have the tangent of 30 degrees. This relationship ends up being 1/2 multiplied by the reciprocal, 2 over the square root of 3. So my answer is 1 over the square root of 3. So coming back to the tangent here, I know that one of my angles happens to be 30 degrees. I'm not going to add the 2 pi k here because I'm not asking for all angles that satisfy it. I'm looking for it in a particular interval, so I'm going to answer it in that interval. Yes?
So when you put in 30 degrees, is that more like a guess and check kind of thing? You see if this was the angle that matched up with one?
It's either the 30 or the 60. So the question was, is it a guess and check? And it's either the 30 or the 60 because I see the square root of 3. Okay. So it's just a matter of making sure I've got the relationship correct. And once you do one of them, you're like, oh, I know the other one has to be. So you'll have the opportunity to learn those off the top of your head by the end of this quarter. I'm giving you this opportunity to learn these off the top of your head. In other words, you'll have them memorized by the end. The other place in which I have 30 degrees is 210 because I know in quadrant number 3, they're both negative. So negative over a negative is the other place in which that satisfies it. The other two quadrants, quadrant 2 and 4, they're negative answers. So if I were asked to ask the exact same thing and I'll do it down here. If I was asked the exact same thing and I want the tangent of theta is equal to the negative 1 over the square root of 3, and then I'm going to look for an answer, and again, this is in the interval between 0 and theta, and I'll do this in radians, so 2 pi. Then I'm going to look for the places in which I have one of the values as positive and one of the values is negative. And so that's going to be happening in quadrant 2 and 4. So my answer in this case is I would answer it in quadrant 2, which is the 65 pi over 6, or the 35 pi over 6. That's in quadrant 2, and 11 pi over 6. That's in quadrant 4. And that's because of the fact that it's asking for the negative of that value. Okay? So when you have something that looks like this, I know there's another one that came up like this. I had the square root of 3 times the tangent of theta is equal to 1. You're solving for the tangent of theta, so you do need to isolate the tangent of theta by dividing both sides by the square root of 3 first. So the tangent of theta is 1 over the square root of 3, and that's how you would start those. Okay? So any other questions on the homework?
So they're asking for all the ones that are...
If they're asking for it in an interval, then you're going to find all the ones in that interval that satisfy it. If they're asking for it all real theta values that satisfy it, that's when you slap on the plus 2 pi k.
When they say exact solutions, it has to be in...
So if they want exact solutions, you do have to give exact, like the pi, you actually have to type in pi over 3 or pi over 4 or whatever the answer may be. Yes?
I don't know if it's going to be degrees or radians.
So if it doesn't say anything, we default into radians, but it will on the homework tell you which interval, and that tells you what the answer needs to be in. So if it's telling you the interval in terms of radians, you put it in radians.
Yeah.
If it tells you the interval in degrees, you put it in degrees. Okay? Anything else before we go back to the lovely, let's do these lovely and exciting, yes?
So some of us are confused on why you chose those particular angles with the square root of 3 over 2 and 1/2, because there's 2 per quadrant.
Right?
Why would you not choose the other ones? Instead of 5 pi over 6, why not choose 2 pi over 3?
Okay, so the question was, why did I choose the answers of 4 pi over 3 or 5 pi over 3 or over here the 30 and the 210? And that's because it depends on what this is. This is a positive value. So because that's a positive value, the only time tangent is positive is in quadrant 1 and quadrant 3. Those are the only 2 angles I can choose. If I'm down here and I'm looking here, this is a negative. I'm looking for where tangent happens to be a negative value. That's in quadrant 2 and quadrant 4. So my answers will be in quadrant 2 and 4. Does that make sense? Like when I was doing the sine here, I was looking for which quadrants produced a negative value for sine. That's in quadrants 3 and 4. So that's how you determine which quadrants you choose, is based on if the answer is positive or negative. Did that answer your question? Yes, no, maybe? Not really? Ask it again and maybe I'll get it this time what you're asking.
Just tangent is represented by y and x.
Mm-hmm.
So how do you differentiate between those when you're looking at those points?
Okay. So the question was, when I'm looking at tangent, my tangent of my angle, I can represent it as y over x. I can also represent this as the sine over cosine. Okay? These are equivalent for me and for you as well. And if I'm trying to determine where the tangent of my angle is, give me one of the tangent is either square root of 3, it's just 1 over the square root of 3, or it's 1. Which one do you want to use? Okay, so I have 1 over the square root of 3. This answer, is it positive or is this answer negative? Positive. So where was tangent positive? Which quadrants? So that's the first thing. Which quadrants is tangent positive? Well, quadrant 2 is not positive because if I look at quadrant 2, now remember, in my first quadrant, both my x and my y are positive. In quadrant number 2, my x is negative, my y is positive. Is that going to give me a positive tangent as an answer? No. So down here, they're both negative, so that's where tangent's going to be positive. So down over here, I have a positive and negative. Whether you define it as x over y or sine over cosine, the place in which tangent is positive is up in quadrant 1 and down in quadrant 3. So I know that's the ones that I'm chasing. Does that answer your question now? Okay.
So that's clear, thank you for that. But how the problem's actually read is confusing to me, like what it's saying. I mean, like, okay, yeah, do that, but like how do you know it says square root of 3 tangent x in parentheses equals 1 or negative 1? How do you know which one is like goes where?
When we're doing this, we are always isolating our function. Is the square root of 3, or is tangent isolated? So the question he had was, I was given this. Say on the homework, I was given this. Is the tangent isolated? Is my function isolated? What does it mean to be isolated? What does it mean to be what does it say? So when we say isolated, my function has to be all by itself?
Okay, I got you. You just divide.
Yeah. He's got that. He's just asking if I'm awake. Okay, yes.
I think the problem was recognizing that it had.
That's okay. This is the first time you're seeing it. Now, when you see it again and again and again, you're going to say, holy crap, I know how to do this. Anything else on these homework questions for 10.2, which is not due until tomorrow?
Yeah,
Yeah, it's due tomorrow, because we finished 10.2 yesterday. Anything else?
Yeah, so when it says tangent of x, that really means tangent of theta?
Yes. Yep. Yep. Theta is just a placeholder, just like x. Anything else I can help you all with before we get into identities? Woo, identities. All right, so look at these identities. Oh, so delicious. This is where we were when I mistakenly pulled this down and started it, and you all had that deer in the headlight look. Now you've had an opportunity to explore a sine, cosine, tangent. We're going to look at the identities. Now, when you're proving an identity, you do not get to work both sides. Just like when we were doing proof by induction, you didn't get to work both sides. You work one side or you work the other side. We did this in class last week. I'm going to do it again, however. This time I'm going to choose the right-hand side. When I did this in class last week, I did the left-hand side. This time I'm going to choose the right-hand side. So the first thing you do is declare the sides that you're going to work on, so right-hand side. So you declare it and then you write it down. So we have the secant of theta minus the tangent of theta, the quantity squared. So you declare it and then you rewrite it. Now you start messing with it. This has the form a minus b, the quantity squared. So what I'm going to do is I'm going to expand this out. This becomes a perfect square trinomial. And I have a minus b squared becomes a squared minus 2ab plus b squared. That's what it looks like as a perfect square trinomial. So I'm going to do the same thing here. I'm going to use that knowledge and expand that out. It'll be my first term squared, which is secant, so it'll be secant squared of theta. And then it's going to be minus 2 times the secant of theta, the tangent of theta. And then it's going to be plus the tangent squared of theta. So again, all I'm doing is I'm following the rules for multiplying out a perfect square trinomial. Okay? The next thing I'm going to do is I'm going to look at the fact that I have secant and tangent, and I'm going to turn everything into sine and cosine. Right now I'm just going to go out of control and write everything in sine and cosine. Secant is the reciprocal of who? So this is going to be 1 over the cosine squared of theta minus 2 times 1 over the cosine of theta. How do I define tangent? So sine over cosine, and then plus sine squared over cosine squared, because it is tangent squared. I'm going to stop, let you digest the deliciousness of it all. It is delicious. Scrumptious even. All right. Is there any questions so far before I move on?
That would just be an understatement.
Okay. Do they all have a same common denominator? Yes. I am not allowed to clear denominators because basically without the equal sign I just have an expression. I am not allowed to clear denominators. All I am allowed to do is put them all over the same thing. So what I have in the numerator is I have 1 minus 2, the sine of theta, plus the sine squared of theta, over the cosine squared of theta. That's all I'm allowed to do. I cannot clear denominators because this is an expression at this point. So I don't get to multiply everything by cosine squared to get rid of the cosine squared in the denominator. That numerator, does that look familiar?
Yeah.
Not quite. We come over here, what does that numerator look like? Kind of looks like this one, right? If that's what it looks like, what did I start out with? So I'm going to take this numerator and I'm going to factor it into its perfect square. So this becomes 1 minus the sine of theta, the quantity squared. I'm not done yet. I'm just going to pause, see if there's any questions, comments, or concerns. In the denominator, I know that the cosine squared of theta, let me do this in a different color. In the denominator, I know that the cosine squared of theta is equal to 1 minus the sine squared theta. That's just using our identities. As a reminder, I'm using the fact that I know that cosine squared of my angle plus sine squared of my angle is equal to 1, and all I did was solve for cosine squared. Do you all agree to that?
Was that cosine squared plus sine squared equals 1?
Yep, all day long. So this right here has the form of a squared minus b squared. Two things squared with a minus between them. What does this factor into if I have two things squared, if I have a squared minus b squared? It's going to be a minus b, and what else? A plus b. So using that knowledge, this denominator is 1 minus the sine squared theta, which is equal to 1 minus the sine of theta squared in the numerator. And in the denominator, I'm going to factor as the difference of squares. So 1 minus the sine theta, 1 plus the sine theta. So mostly this is just recognizing patterns. That's all we're doing is recognizing patterns. That's it. That's why we start with the other one first. Chapter 9 is to recognize patterns and to show you at least it's not proof by induction. That's the reason why I start with chapter 9. Now what?
Just for my own brain, you substituted the cosine square for 1 minus 1 because of the sine square.
Yes. So the question was, back here, when I had cosine squared, I replaced it with 1 minus sine squared. The reason I'm doing all of this work is I need to keep my eye on the prize, and this is my prize. I need this thing to look like 1 minus sine theta over 1 plus sine theta. Eye on the prize. So then I am right here. So I'm going to do some cancellations. This one will cancel in here and leaving that 1. And so I end up with, I get some thumbs up in the audience, that's awesome. 1 minus the sine theta over 1 plus the cosine theta, which is the left-hand side. Done. Yes?
Is that supposed to say cosine on the bottom there?
Oh, it should be sine, thank you. Thank you for that. Let me erase. How was that? You all can choose the side. Some sides, if you choose one side, will be easier than the other side. You all get to choose the side that you want. So the best way to choose the side, this is strategies here.
That was right-hand side or left-hand side?
I started with the right-hand side, and I finished with the left-hand side. Okay? So some of the things that will help you is try using the side that has the most terms. The most complicated side is going to give you the most to work with. So when you start doing these, try to choose the side that has the most that you can work with. That's the easiest way to do it. Now remember, we have reciprocals and we have quotient identities. The reciprocal identities, of course, are the 1 over the cosine theta is equal to the secant theta. That's what the reciprocal identities are. You can use Pythagorean identities. Those Pythagorean identities are the cosine squared theta plus the sine squared theta and all the equivalents. Conjugates are your friends. Conjugates are something that looks like this. So if you have a minus b, its conjugate would be a plus b. So you may have to use conjugates to introduce those. They will be your friend. They will sneak out of the house with you on the weekends, friend. You're going to become close friends with conjugates. The other thing is whenever you see the number 1, we can always replace the number 1 with the cosine squared theta plus the sine squared theta. So when you're sneaking out of the house with your conjugate friend, and somebody asks you if you'd like a drink, and you're going to say, yes, I'd like cosine squared theta plus sine squared theta drinks. You are going to get so many friends that way, I promise you. Yes.
Because those are, we're getting 1 because those are inverse of each other?
Which one is going to give me 1?
The cosine and the...
This is the identity that's true all the time.
Is that because they're inverse of each other?
No, it's just true all day long. It's the Pythagorean identity. Okay, so please attempt those 3 and I'll come around and help you. So on these that are on the test, and there's a couple of identities on the test, we're going to baby step into the identities. After the test, when we come back to chapter 10, we're going to do more delicious identities. But these are just going to baby step into identities. So on A, I'm going to choose the side that has the most information. So on A, I'm going to choose the left-hand side. So starting with the left-hand side, or not. Maybe not. Left-hand side, my pencil's not working, my finger's not working, that's pretty awesome. Okay, so just a minute. I'm going to have to stop this and restart it, so hang on a second. All right, so I'm going to choose the left-hand side because it has the most information, left-hand side. So I'm going to rewrite the left-hand side, or not. Okay, so the left-hand side is equal to, and I rewrite it, tangent of theta, cosine of theta. How do we define tangent? It is sine theta over cosine theta. I still have the cosine theta there. If I want to, I can write it over 1. My cosines are the same, so they're going to cancel themselves out. So I'm left with just the sine theta, which is my right-hand side. How is that? All right? Let's take a look at the next one. Again, I'm going to choose the side that has the most stuff. So I'm going to use the tangent, cotangent. So the tangent of theta, so I have to first declare my left-hand side. So left-hand side. And then I have the tangent of theta, cotangent of theta. But tangent of theta is equal to 1 over the cotangent of theta because they are reciprocals of each other, times the cotangent of theta. These cancel out, and I end up with 1, which is the left-hand or right-hand side. How was that? Not too bad, I hope. Going down to the next one, I have the cosine of theta over sine squared theta. You get to choose whatever side you want. I'm going to choose on this one, I don't know, what do you want to choose? Right-hand side? Okay, cool. I'm going to choose the right-hand side. And so we rewrite this as the cosecant of theta, cotangent of theta. Because the left-hand side is in terms of sine and cosine, I'm going to replace these with their equivalent sine and cosine. Cosecant is 1 over the sine of theta. Cotangent is the cosine of theta over the sine of theta. So this is equal to the cosine of theta over the sine squared of theta. Eye on the prize, there it is. So I have my left-hand side. How are these? Delicious. Cool. Scrumptious. Okay, please do the next 2. Okay, so on D, the side that has the most terms is the left-hand side, so that's the one I'm going to choose. You can absolutely choose, like Lauren did, the right-hand side, but I'm going to choose the left-hand side because it has more terms. And Lauren did it with the right-hand side, and she did great. She still got there. So I'm going to choose the left-hand side, which is going to be, rewriting it as the sine of theta over 1 minus the cosine squared theta. But we know that 1 minus the cosine squared theta is equal to the sine squared theta. It's not squared in the top, so let me erase that. It's not squared up there, it's just in the denominator. And so this is equal to 1 over the sine of theta. And 1 over the sine of theta is equal to the cosecant of theta, which is, of course, my right-hand side. Yes?
How did you get on the denominator for sine squared? How did you get that?
Do you see this lovely thing right here?
Yes.
That is the basic identity, the Pythagorean identity, but solved for cosine squared or for sine squared. You're going to become one with that one. You won't even have to memorize it because you will anyways, whether you want to or not. It'll be scrumptious. Okay, on this one, what do you all want to choose? Left-hand side because it has more terms to play with. Left-hand side. So I have the secant of theta over 1 plus the tangent squared of theta. And you end up with cosine. So we have all the Pythagorean identities. If you don't know them, that's okay. You can work through them by realizing that if you have sine squared theta plus the cosine squared theta, is equal to 1. I need the tangent, so if I divide this Pythagorean identity and divide everything by cosine squared, I'm going to end up with the tangent squared theta plus 1 is equal to the secant squared theta. So, going back to this, I'm going to replace the denominator. This is the secant theta. I'm going to replace the denominator with a secant squared of theta. So just like before, this is 1 over the secant of theta, which is a reciprocal identity of the cosine of theta, which gives me ... the right-hand side. How was that? Okay, cool. Tomorrow, when I see you all, we have a couple of more identities. See how they get so much more delicious? I mean, they're just so scrumptious. I'm going to talk a little bit about tomorrow about the domains and range, but very, very little, and then we're going to go into the unit test. So tomorrow we're going to do a couple more identities, and then we're going to go into 11.2. We're going to jump to 11.2.